Section 5.3, solving systems using eliminations. Now your target here is to be able to solve systems of linear equations in two variables by using elimination instead of substitution or graphing. Now always when you're starting with elimination, you want to start by putting the equations in the standard form. Now when I say standard form, I mean both x and y are on the left side of the equal sign. Now let's start with these two equations. 2x minus 8y equals 18. And 2x plus 4y equals negative 6. So see how both x and y are on the left side of the equal sign, and x and y are also lined up and down. That's how you put it in the standard form. Now, if necessary, we need to multiply the equations by a constant to make one pair of the coefficients, so either x or y, opposites. When I say opposites, I mean they're going to have the same coefficient or the same number, but one will be positive and one will be negative. Now I'm looking at those equations. I see that x has both 2 on both of those x's. So we just make one of those 2's negative, we can get going with our elimination. So I'm going to make the bottom equation negative. When I do that, I'm going to multiply everything on the bottom equation by negative 1. So it's like I'm distributing negative 1 to 2x, negative 1 to 4y, and to negative 6. So I'm going to rewrite the equation on top. I'm still going to rewrite 2x minus 8y equals 18. That's the same equation from up top. The second equation is going to have all those signs switch because I multiplied by negative 1. So now I have negative 2x minus 4y, but equals positive 6. Now see how negative 2x and x are opposites? We have a positive 2, but now a negative 2. That's what we want to use it to do elimination. And our next step is to add the equations together. So it's almost like, I think back to elementary school where you had an addition bar down here. You're adding them up. So eliminating one of the variables. So when I say adding them up, I'm just going to go straight down. So now 2x minus 2x, that's just 0. Negative 8y minus 4y, that's negative 12y. And 8 plus 16, that's 24. So now see, all I have is a y. There's no more x. So I can even just erase that 0. There's nothing there. All I have is negative 12y equals 24. And to solve for y, I just divide by negative 12. So now y equals negative 2. Boom. So remember, when we're solving systems, we need both an x and a y. So we have y equals negative 2. Now to get x, we've got to substitute that negative 2 into one of the original equations. It doesn't matter one. We can do either one of those original equations up there. I'm just going to do the top one since that seems less messed with. So I'm going to have the top equation, I'm just going to rewrite it. It was 2x minus 8y equals 18. 2x minus 8y equals 18. Now, I'm just going to substitute this negative 2 in for y. So I'm still going to have 2x minus 8, but that y is now negative 2. And that equals 18. So I'm going to solve for it. So negative 8 times negative 2 is positive 16. So I have 2x plus 16 equals 18. If I subtract 16 from both sides, I have 2x equals 2. And then when I divide both sides by 2, I have x equals 1. So x equals 1 and y equals negative 2, then our final answer would be 1, negative 2. Let's do a couple of homework examples. So let's go to the next page. We see number 1, solve that system of equations by elimination. Well, if I look at this equation, I see that we already have y's being opposites. We have a positive 3y and a negative 3y. So I can just start adding stuff up immediately. I'm going to add those equations. 5x and 10 minus 5 equals 5. Now if you have 5x equals 5, 1, there you go. Now to get the value of y, top equation 4x 3y equals 10. I'm going to put this x equals 1 into the x from that first equation. So I'm going to have 4 times 1 plus 3y equals 10. 4 times 1 is 4. So now I have 4 plus 3y equals 10. I subtract 4 from both sides. I get 3y equals 6. And then when I divide by 3, I get y equals 2. So if x equals 1 and y equals 2, our final answer is 1, 2. All right, let's do a tougher example. Go to the next page. Look at number 7 here. Number 7, we have negative x plus 4y equals 1, and 5x plus 2y equals 17. Well, I still need to eliminate some variables here. Now, I see that we have a negative x. We already have x by itself on one side, and then a 5x. So all I need to do to the top equation to be able to make the x's opposite is multiply the top by negative 5x on top and a positive 5x on the bottom. Equals 1. I'm just going to rewrite the bottom equation. Y equals 17. And now that my x's are opposites, I can start adding the equations together. 5x and negative 5x will cancel out. And we're going to have 22y equals 18. Excuse me. I forgot to multiply the 1 by 5. So, pardon me. That is my mistake. So I forgot to do the 5 times the 1 up there. So that should be 5. So then that would add 22. So 22y equals 22. We know y just equals 1. Now to solve for y, or excuse me, to solve for x, I'm just going to have to plug y in for one of these equations. I'm just going to pick the bottom equation. It honestly doesn't matter which one. I'm just going to pick the bottom. So I'm going to still have 5x plus 2. But remember, we're replacing y with 1 now. So that's a 1 in there instead of a y. And equals 17. So now it's 5x plus 2 equals 17. 5x equals 15 if we subtract 2 from both sides. So then x has to equal 3 when you divide both sides by 5. Then our final answer would be 3, 1. Let's do one more example. Let's look at number 8. I'm going to draw that line there to separate. So number 8 is a tough one. We have 5x plus 6y equals 2, and 9x plus 4y equals 24. Now we want to solve the system using elimination. Now when I look at those variables, I don't see any variable that's by itself in terms of having the coefficient of 1. Every one of those variables has a coefficient. Now at this point it's personal preference, but I'm looking at how y has a 6 and a 4. Now remember, think about common factors between numbers. Now do not write this down. Do not write this down. I just want you to see it. Do not write this down. 6 can go to 12, then 18, then 24, for example. 4 can go to 8, 12, 16. So they both can go to 12. Well, 6 times 2 is 12. 4 times 3 is 12. So we multiply that top equation all by 2 because it's with the 6, and that bottom equation all by 3 because it's with the 4. Then I'm going to have to make one of those negative. Then we can start using elimination. So I'm going to erase these. So just because we need one of them to be negative, it doesn't matter which one, I'm just going to make the 2 on top negative. So first I'm going to distribute negative 2 to all three of those numbers. So I have negative 10x minus 12y equals negative 4. And on the bottom, I'm going to distribute that positive 3 to all three of those numbers. I'm going to have 27x plus 12y, equals 72. So now because those y's are now opposites, I can add up the equations. So I'm going to have 17x Those y's go away. Then equals 68. I'll divide both sides by 17. I get that x equals 4. Now x equals 4. Now all I have to do is take this x, put it back into any of the original equations. It could just be the original one before we even started multiplying stuff. I'm just going to pick the bottom equation. So I'll do it down here. So I'm going to have 9 times 4 plus 4y equals 24, because remember we're trying to solve for y. And 9 times 4 is 36. So 36 plus 4y equals 24. So I'm going to subtract 36 from both sides. I have 4y equals negative 12, because 24 minus 36 is negative 12. And then when I divide both sides by 4, I get y equals negative 3. So if I have negative 3 for y and 4 for x, my final answer, squeeze it over here, would be 4, negative 3.